So let's look at question number 12. That's from June 2020 paper. So dyes in black ink are separated using a strip of filter paper. So we are using a strip of filter paper. So filter paper here, it's like this, right? And a solvent. Then our solvent will be basically maybe in our beaker. So we have that filter paper and a solvent. Then the ink is placed on a filter paper and the position of the ink is marked in pencil. So we have our filter paper. Then after having our filter paper, we have our dyes, that's black ink, right? So we have our black, right? It is placed on a filter paper. Then after it is placed on a filter paper, we then hear that the position of the ink is marked in pencil. So we have to mark the position in pencil. So this will be the position that will be marked in pencil. So we have the position of that being marked by a pencil. Then after that, the filter paper strip is dipped into a solvent. So we find that this paper here is then dipped into a solvent, ensuring that the solvent is just below the ink. So let's say we are now adding the setup. So it is dipped just below the solvent, ensuring that the solvent is just below the ink, right? So right here we have our solvent just below the ink. And the reason why we have our solvent, so our solvent is this one that is within the beaker. So that is our solvent. So it's just below the ink. And the reason why it is like that is so that we ensure that this ink doesn't mix with the solvent. So if it mixes with the solvent, it dissolves in the solvent, and therefore we are unable to track how it goes through, because normally the solvent would have to be sucked by the filter paper, or for example, you place a paper in water and then you find that the water starts to go up the paper. That's what exactly happens on the filter paper, where we have our solvent starting to move up. And normally it moves up by capillary action, which is the same as the action that happens in xylem vessels. So getting to our question again, now that we have understood the question, let's go to the first part. Name the process that is used to separate dyes in black ink. So that process is called chromatography. So chromatography is the name of the process. And suggest with a reason a suitable solvent. So with the reason, we have to suggest a suitable solvent. So in chromatography, if we have, let's say, a solvent, let's say we have a solvent, right? We have two things that are there. We have organic solvents as well as inorganic solvents. So let's say, for example, we have H2O. H2O, or water, is an inorganic solvent. So it is able to dissolve all things that are inorganic in nature. And then organic solvents dissolve things that are organic in nature. And in this question, we have dyes specifically. So we are going to look for an organic solvent. And the reason why we use that organic solvent is the fact that it allows the ink to dissolve in it. So, getting back to our business, suggest with a reason the suitable solvent. So the solvents that we would have to choose would be organic in nature. So we can have, for example, ethanol. It's an organic solvent. We can also have alcohol. Alcohol and ethanol, they are still the same because they are all alcohols in nature. And we can also have acetone. So these are the ones that we can be able to choose, or even more, but they have to be organic in nature. And the reason why we choose them as our reason is they enable dyes to dissolve. So since they enable dyes to dissolve, we choose them. Then number 3, explain why the position of the ink is marked in pencil and not ink. So the position of the ink is marked in pencil. It is marked in pencil, not ink. It's particularly so that we can be able to always notice the position, because the pencil does not dissolve in what? In the solvent. So the position will remain the same. If it had been used as ink, it would have dissolved and we would be unable to see the results clearly. So when you're now giving your answer, we are now having to explain why the position is marked in pencil. So the position is marked in pencil. Then we say because pencil does not dissolve in the solvent, therefore our results will not be interfered. They will not be interfered with. If we say that they will not be interfered with, we then have to just give it as a summary, is that we will obtain what? Is to obtain accurate results or comparison. So if it dissolves, we will not be able to have a comparison to see what exactly has happened. Then we go with our question on B. State the method which can be used to separate, number 1, ethanol from water. So if we are to separate ethanol from water, ethanol and water have 2 different boiling points. So if they have 2 different boiling points, we are able to separate them. So ethanol has a lower boiling point, whilst water has a higher boiling point. So if we are separating things based on their boiling points, we call that fractional distillation. So the method there that is used is called fractional distillation. Then a method which can be used to separate iron filings from sulfur. Iron filings, they are able to be magnetized, while sulfur is not able to be magnetized. So the method that we will be using to separate the two is therefore called magnetism.